Yeah, so I think we should just give them a close-up of this.
Hey there, Shane Stemlow here, and we're going to tell you how we separated water to make a hydrogen gas. First off, what you're going to need to take is a mason jar that we just bought from Menards.
You can't only buy one, by the way. You have to buy 12,
yes,
apparently.
you have to buy a whole bunch.
Isn't that ridiculous?
So,
alright.
Whatever. And then what we did was we bought a pack of rubber sealing things. We don't even...
We'll get to that.
Yeah, hole gormets, and we drilled a hole.
2 of them. Dose.
3 actually.
3
holes
Trace.
into the top of the mason jar, and kinda.
I don't know what.
Now there's holes in here, but
and
we also bought. Well, yeah.
We bought 2 zinc. It can be any type of metal as long as it conducts electricity. Rods. These are actually not rods, but they're like
screws.
They're screws, I guess, like you put into the ground or something. But like here's a close-up. You can see these 2. One will be your positive and your negative for your electric current, and it will go. You want it about halfway in, maybe a little bit more than halfway. We'll get to that.
And with the ridges is more
surface area.
Yeah, it has more surface area, so that would help out.
Yeah, it does work with the screw part.
And the rubber hole gormets are very
important.
Yeah, well, yes, and sometimes they will break. And what I did was I took a wrench and I screwed in the screw as much as I could, but like to where I could get this nut on here. And I put the nut on, and I just screwed the nut until I got it to the length that I wanted it on there. So that's what I did to get that in without breaking it.
The rubber pieces here they are very important, because what you want is, as I said, there's an electric current, and you're going to be running it through water like this. But the electric current, since this is a metal lid, and apparently you can't buy mason jars with plastic lids, we have a metal lid, and that's a problem, because if you apply electricity here, the lid is going to take the electricity instead of the screws. So to fix that problem, we actually had a kind guy at Menards who talked to us about how he did it, and we took these rubber things. And what they did is they actually touched the metal lid, but contain an airtight environment within, so that your 2 conductors aren't even touching the lid. So they're actually just going through and touching rubber. Rubber doesn't conduct electricity, obviously, so it keeps the electricity current through the water instead of the lid. And we also applied caulk to the top. Didn't work very well, but it works. It's an improvement. But this is to make sure that air won't get through the rubber, increasing all of our efficiency.
Definitely one of our limitations.
Yeah, definitely a limitation.
Of how, and also the rubber sealings would sometimes break on us.
Yeah,
so
we actually do have a break down here, but I think it's all good.
Airtight,
yeah,
and
it's
didn't
pretty
touch
good.
The rubber kept
works.
it from touching the metal straight on. Also, we have a 90-degree adapter. Also showed to us by a kind Menards man.
Yep.
Of a metal and plastic.
Screws right in.
We probably could have put the plastic in the hole instead of the metal, just to eliminate the, electricity problems. But it still works how we
What this will do is, it's where the gas inside the mason jar builds up. Once it creates enough pressure, it'll push it through this 90-degree adapter, which you can't really see. Maybe you can see the hole, right? Yeah, I see the hole there. It goes straight up to the 90-degree adapter. It'll push the gas through this tube, and this will be your hydrogen gas output here. We have balloons. We have a water bottle where it'll collect the gas on top, which with any draft like we have in my garage, it will pop bubbles, which has been another limitation, but we can fill a balloon pretty efficiently, and it works like a charm, actually. It takes about 10 minutes to get a reliable source, to blow it up, and that's about the increment of time we'll be using in our experiment today. But
also, you need 2 6-volt batteries. Would be very helpful. If you're willing to use your car battery, you can use that too.
that also works.
Most people don't want to use that.
We have 2 6 volts, and we just hooked them both up, and we'll show that later.
Also, we use salt to help conduct the electricity faster.
Within the water, we'll use 2 tablespoons.
We also, since there was no place that we could find, we had to build our own wire connectors, and we realized once we started putting it together that the things don't really stay on too well, so that's also another
plan ahead. Definitely.
Yeah,
we did
limitation.
Not. Isn't that ridiculous? We had to make our own wires. Like, jeez.
I think more people would want to buy these.
Do you have any Christmas Menards?
Also, you need a lighter to ignite the
hydrogen.
Yes, and I think that's all the materials.
I do believe
and
that is all.
How to build this. And what we're going to do right now is we are going to show you how this all works. We are going to fill this up with water so that these screws are in the water, not completely to where it's touching the lid, and not also touching the 90-degree adapter that's also stuck down in a hole, so that the 90-degree adapter can collect the gas and push it through the tube to the water bottle. So we'll pick you right back up before we start our little experiment here. Be right back.
All right, and we're back for part 2 of HHO gas. All right, so here we have a clean mason jar. You can actually use any jar that fits this lid, which we happen to have 12 of them again, just because the lid is the only important part. There's just a jar is a airtight container that works.
This is the jar that we had all our previous ones on, and it looks pretty nasty right now.
It's like a black, almost like it's if you run electricity through it, it will end up building up chlorine, and you'll have to dump after
from the salt.
Yeah, from the salt in the water. So here we go. We have a clean mason jar here. We're gonna take just regular water.
Regular. Doesn't really matter what type of water. It can be tap water.
Yeah, tap water actually helps, but I don't feel like running inside, so we have a bottle of water right here.
And we have some salt that Rylan will add to the...
We will fill water up to about a little bit less than this line right here, about here. You don't want it too full, you don't want it too less. That's just about a good spot where we found. So, here, let's just fill this up. Let's go. Any day now, it's kind of awkward. And about right, let's see. We're going to do a little bit more than that. And I spilt on myself, fantastic. Let's see. That's about good right there. A little bit less. And we'll go ahead and put that down. We have 2 just tablespoons of regular salt. We're going to go ahead and do that over the mason jar. Let's see. And I'm spilling. This is now way too low.
And it's alright if you get a little bit more. You just don't want to put too much in there, because then it will start separating more of the salt instead of the actual water.
Yeah, you'll get a ridiculous buildup of chlorine.
Yes.
It gets pretty nasty, and then it ends up, the chlorine attaches itself to the screws, and you end up without any electric conduct. It just doesn't have surface area to get electricity to the water. So, gosh, I grabbed the other container. What was I thinking? Okay, there we go. So there's 2 tablespoons. You mix it up. Make sure it dissolves so it's not just sitting on the bottom. It's really cloudy. Now just give it a good mixing. And there we go. You'll see how the water line kind of increased from the salt, but that's plenty right. Pop that bad boy in.
We're going to place the contraption on the tap and screw on the lid.
Make sure you get it nice and tight so there's no air leakage
place the water bottle or the tube into the water.
The hydrogen output, you want it to be barely breaking the surface of the water so that it has bubbles piling up on top. I'm going to go ahead and close this garage door after we start so there's no draft in here. And then here, we'll get the batteries hooked up.
You want to make sure that you go each positive to one of the...
Both positives have to be to one of the screws, and both negatives have to be the other.
Want to make sure you do that. And then
here's pretty sure the negative's in the middle, right?
Yeah. This is also one of our problems we've had is the
Clamps
falling off.
Ridiculous.
Yep, move this around. And also, don't really have the clamp like that as shown. Get to stay. Not wanting to.
And we have, once you get it, clamps are a real problem.
Probably could have went with bigger ones, but
probably should have. Yeah,
this is the first time we've ever done this.
Yeah,
and
we're not pros.
Now we've.
Yeah, you'll notice now that we have a complete electric circuit here. If we get down and dirty and look inside,
you can see bubbles kind of coming from the left one, the left screw.
Let's see, I can't. Yeah,
it's hard to see. You can kind of see it there.
The bubbles, that is actually the water separating, and the bubbles are the gas that we will be collecting into our water bottle here. And give it about 10 minutes. We'll come back out, start the video, and we'll light this baby for you. Should we just leave that running?